Welcome to this lecture. In this lecture, we will talk about indoor environmental quality, starting with the definition and starting with a list of the main components and a description. And later, we will talk about how to achieve good indoor environmental quality by examples of design, technology, and tools that you can use. Indoor environmental quality is a mission difficult to accomplish because it comprises several elements. You need to consider the design, the analysis, the operation of the buildings in terms of energy, health, comfort. The definition you see here comes from ASHRAE. And in this lecture, we will cover mainly four aspects that are acoustic comfort, indoor air quality, thermal comfort, and visual comfort. All together, let's say they enable us to define the level of indoor environmental quality. Thermal comfort has been widely analyzed and is defined by ASHRAE as the condition of mind that expresses satisfaction with the thermal environment and is assessed by subjective evaluation. This means that you have to consider both some measurements of the thermal environment to evaluate comfort, some numbers such as temperature and airspeed, and also the subjective evaluation of the people experiencing that level of comfort. And there are ASHRAE and ISO and EN standards that enable us to understand how to conduct these measurements and this subjective analysis. Similarly, but with a slightly different perspective, we have indoor air quality. In this case, there are two steps of the definition of acceptable indoor air quality. The first part refers to the fact that we have to make sure there are no contaminants at harmful concentrations. While the second one is like for the comfort, thermal comfort one, it's about the preference of the majority of people. And also in this case, we have a number of standards and guidelines, both in Europe and in the US, that enable us to design indoor air quality. Visual comfort doesn't have a clear definition as in a standard, but again, is the subjective evaluation of the level of lighting, and it depends on the human capability of balancing different lighting levels. And also in this case, we have standards that enable us to design and evaluate daylighting and lighting in different type of spaces. We have then acoustic comfort, and acoustic is quite interesting because recently we moved from the concept of having no noise as the main target of acoustic design to the concept of soundscape. So here we have the concept of perception, understanding, and experience related with the context, related with the fact that in certain context you may want to be listening to some sounds more than noise. And we have some standards again for different environments to help us in understanding whether we have a good acoustic comfort. So how to achieve good indoor environmental quality, how to design such a complex building, which is the theater in Beijing, China, but also how to design this in a normal residential building. You can start thinking at an example of design. If you think at natural ventilation, normally you would start from the loads that you have to satisfy in terms of thermal loads and air contaminants. You estimate the neutral pressure level, define the size of openings, evaluate the impact on daylighting and architecture of the size of these openings, and then you may want to consider sound and noise, and then the link with HVAC systems. And guess what? The best thing you can do at the end is to recheck all these things in an iterative process to make sure they all work well together. And this slide, which is borrowing a term from project management, a comparison between waterfall design with sprints-based design. In waterfall, you would start to analyze one aspect after the other, and so on. And done with thermal, you move to daylighting, done with daylighting, you move to air, and so on. My advice is to start to be thinking in the same way you think with agile project management. Do a run, do a sprint, have all the pieces working, check all of them together, and then if you make a modification, recheck again and work always with the solution that in principle works, but is improvable, and you check the different aspects. An example of technology that you can use for indoor environmental quality is this system we designed within 4R in EU project. It's a simple fun, but it has an advanced control algorithm that enables to control basically the rotational speed according to the thermal conditions of the room. And a good example of integrated design is that, yes, we satisfy thermal comfort with this simple design very well with this technology. But what about noise, link with HVAC system, architectural constraints such as the internal height? You need to consider all these things together to make a robust technology concept enhanced product. Lastly, a tool that you can use. This is from CBE and it's a thermal comfort tool, and I think it's a great tool because it enables you to make some preliminary condition analysis of the conditions and to compare the output you would have with different standards. And it's crucial to remember that with thermal comfort sometimes it's not something you must have to do, you must do just because the law tells you. It's more about getting the things right, and so comparing what different standards have to say is very relevant because you may get complementary informations. Thank you for your attention and get ready for the next lecture.